Hi, this is Tony Northrup for Train Signal, and in this video lesson, I'm going to discuss creating a disaster recovery plan for the SSCP certification exam. Disaster recovery planning is part of business continuity planning. It's the most fun part, really. It's the part where you get to imagine some sort of disaster happening. Now, there's nothing fun about disasters, but planning for it is kind of that post-apocalyptic thing, you know, where you imagine what you do when the zombies attack. So anyway, I think it's a good time. Disaster recovery planning covers all sorts of natural disasters and man-made disasters. Things like floods, hurricanes, earthquakes, tornadoes, fire, acts of war, acts of terrorism, government shutdowns, whatever it might be. There's no one format for a disaster recovery plan, but in general, they have some of these elements: a list of requirements, things that you need to get your business back up and running. So that's going to be a facility, a building of some kind, probably. Maybe all your employees work from home and maybe your data centers are virtual, but most people will have a facility with things like plumbing and parking and electricity and maybe phone systems. It's also going to include servers, network equipment, firewalls, internet connection, all the software that you need, everything that you need to rebuild if your facility is destroyed. Just imagine that. If your business is leveled by some kind of disaster, but you're safe, what do you do then? How do you get started again? The DRP will include contact information. You might not decide that you need to go out and buy extra servers so you have them handy, but you probably want to have the phone number of the guy who's going to sell you those servers. Maybe even some phone numbers for consultants who might be able to help you rebuild it. It's also going to have a step-by-step process for recovering everything. Yes, you'll have to have a step-by-step process for installing your system images for your servers and your clients. How exactly do you configure your database servers? How do you configure your firewalls and make them secure? What do you plug everything into? You want to be able to recreate your exact environment. Your DRP will also have a list of priorities. It will show you which services you need to get up and running first. These are going to be your critical services, things that are customer-facing or that other services depend on, your core infrastructure. Losing power is really common in a disaster. Sometimes the disaster doesn't even hit your facility, but it hits facilities nearby. It takes down power lines. I'm right here on the coast of Connecticut in New England in the United States, and we were hit with 2 hurricanes in the last 2 years, and I was without power for more than a week on each of them. And that's difficult, both on me personally as a business and me individually. And businesses generally have a pretty good plan for this. You can see the picture here. This is a large-scale generator. And most large office buildings will have something like this. They lose power, and this thing usually automatically kicks on. They also often have a maintenance plan where they fire up automatically, and you make sure that you pull the old gas out and put some new gas out, that type of thing. A smaller scale way to replace power is an uninterruptible power supply, a UPS. Usually UPSs use big old batteries like car batteries, and they just store electricity from your regular wall outlets, and when the power goes out, they fire up and they keep your computers running for a couple of hours. It can be really important to protect your server infrastructure with UPSs. Nowadays it seems like everybody's using mobile computers, and obviously they don't need a UPS. They kind of have one built right in with the battery that they have. For enterprises, the UPS is really meant to keep things running until that generator comes online, because most generators aren't online. They're offline generators, which means they're quiet. They're not running all day and wasting gas. They fire up after power fails. But unless that generator has a UPS built into it, there's a lapse of a minute or 2 minutes while everything gets started and the engine smooths out and starts serving stable power. And we'll talk a little bit more about backup facilities soon, but sometimes the answer to recovering power is just to go someplace else. Maybe you have another branch office that's nearby, but it's on a different power grid. You can send all your critical employees to that power grid and send your non-critical employees home just to free up their desks. So what if your office building is level? God forbid, right? Well, you do have a few options. I think nowadays a great option is just to send your employees home, but tell them to keep working. Look how happy the fellow in the lower right corner there is. He doesn't care that a tornado just destroyed his office. He gets to work in his underwear. He's thrilled. Another option, like I just said, is to send people to a branch office. A third option is to create a reciprocal agreement with another company or a partnering organization. A reciprocal agreement is an agreement to share facilities in the event that one of your facilities is no longer available. Maybe there's a partner company that's in a neighboring town, and you say, hey, you have a pretty big office. You know, most of your desks are full, most of my desks are full, but if one of us loses our facility, tell you what, we'll send our non-critical employees home, and all the critical employees will pile into this one office, and things are going to be a little crowded for a while, but at least we'll be up and running, and we don't have to rent a second facility. That's a reciprocal agreement. There's a risk with reciprocal agreements, and that's that your partner will tell you to get lost when you show up to use their facilities. They might not contractually be able to do that, but sometimes that happens. The day finally comes when you need to use their facilities, and they say, sorry, we're busy, we're full, we've got no room for you. Here are some more reliable options than reciprocal agreements. A cold site is basically an empty building. You have all your gear and stuff at your main site, all your networks are up and running. Well, if disaster strikes, you have a place that you can use. Maybe the cold site is even just a warehouse or a parking facility, something that you're using in one aspect but isn't critical. You move your critical resources over to this cold site. You call up your local office supply place and you order a bunch of desks and computers and networking cables and everything else you need, and you get it up and running. Cold sites, by definition, don't necessarily have any facilities ready for you, but they probably have plumbing and bathrooms, and maybe the power is on, but there's no wiring. There's nothing actually set up. There aren't desks for people to sit at. It's basically an empty building. Warm sites will have some stuff ready to go. Warm sites will typically have desks and chairs, and there'll be some infrastructure there. It might not be the full redundant set of servers that you have, but you'll have some servers there. Maybe you have half the number of servers and you have services all piled into the servers that you do have available. Things will run a little bit slower, but they'll be running. Warm sites are more expensive than cold sites because you have to buy this extra equipment, but they're way cheaper than hot sites, which I'll discuss next. A hot site is up and running at all times. It's 100% ready to go. You can close your main site and your employees just drive on over to the hot site and get to work. It generally has an exact duplicate of everything at your main site, and the data is backed up continuously. With a warm site, you generally have to pull your files from some sort of backup, maybe your offsite backup recovery center, and get them loaded on the hardware that's there before you can actually get up and running, which means you're down for a couple of days. With a hot site, you're up and running same day, maybe the next day. By contrast, the cold site is going to take you weeks to get up and running, but still better than having to go out and find a whole new facility. What if a meteor strikes and it destroys your ISP? Well, that's pretty scary because nowadays businesses really rely on their internet connections. The obvious choice is to get multiple internet connections, but make sure that they don't use the same channels. If you get two different circuits to two different ISPs, that's good. That will protect you in the event that one of your ISPs has a routing problem or they get shut down, something like that. But it's not going to protect you in the event that a backhoe digs up the conduit that happens to carry both of your ISP circuits. And yes, that happens. I've worked at big ISPs and had customers come to me and said we had redundant connections and they both went down. Well, guess what? They're redundant and they're in the same physical space, which means one threat can kill them both. If you do get redundant internet connections, just be sure that they follow different paths. I have a picture here of a satellite dish, and I'm not a fan of satellite internet access, but it's way better than no internet access. So have your primary be a wired circuit and have your backup be a satellite circuit. They're rather high latency, but they are way better than nothing. Another option for recovering internet access is to send employees home, and hopefully their home wasn't affected by the same disaster. In many cases, a single disaster will impact your employees' homes, but in many cases, many of them are able to be productive. Wireless broadband is another option, especially for smaller organizations that don't have heavy internet requirements. You can get these little routers that connect to the same network that your smartphone uses, and it just takes the traffic from your LAN and sends it across that wireless connection. They can be really fast too. The amount of data that you're using could get pretty expensive, but it's better than having nothing, right? Now, because your wireless broadband provider certainly has a tower local to you, it's not going to protect you against threats that also impact those towers. However, many different types of threats will impact your facility, but they won't impact the tower. For example, a backhoe could take out your internet connection, but the wireless broadband would still work. A service level agreement says we're going to have 99.99% uptime, and if we don't, we're financially responsible to you. That financial responsibility accomplishes two things. It helps reimburse you for the losses associated with not having the service running. It also financially motivates the hosting provider to do good work and to keep your service up and running. So the hosting provider knows that if their service goes down, they're going to have to pay you some fees because of the service level agreement. That means they will be willing to spend some money to provide redundancy. Many hosting providers and cloud service providers have geographic redundancy just because they have this kind of awesome scale where they have tens of thousands of customers. So it's much easier for a hosting provider to justify geographic distribution than it is for any given organization. If you have 100 employees, are you really going to be able to set up data centers in multiple different locations around the world on different continents just in case there's some huge disaster that impacts a single continent? No, probably not. But the cloud services providers can do this, and they share the cost between all their customers. So you can use these cloud services and take advantage of geographic distribution, and it will cost you just a few bucks a month. It's a really great value. Another option besides providing redundancy within the service provider is to use two different hosting providers. With websites, this is pretty straightforward because most websites run on the same sets of software, and you can just synchronize your website from one hosting provider to the other, and it all happens with very little challenge. Cloud services providers, well, they don't have a common set of APIs, application programming interfaces. They'll use different software and different standards, and in fact, they usually hide the software and stuff from you. It depends on the cloud services that you have, but it can be difficult to synchronize them and get redundancy between different providers. So often you're kind of stuck trusting the one provider to keep things up and running for you. Another option for recovering from failed hosted or cloud services is just to bring it in-house. You know, if your web hosting provider goes down, set up a web server on your own premises, or just keep one running just in case as a backup. You might also keep virtual machines available with all the software that you use in your cloud services, so at least you can get them started up and running in the event that there's a serious disaster with your cloud service provider. So backup and recovery isn't exclusively in the domain of disaster recovery, but this is a good chance to go over some basic backup and recovery concepts. Now remember, availability is part of the CIA triad, and for that reason, somewhat benign concepts like backup and recovery are definitely in the scope of security. First, let's talk about all the different types of backups, at least the commonly accepted types. The first is the full backup, and the full backup takes everything, every file, every database, and it copies it to whatever your backup media is. Now, you'll see the third column there says archive bit cleared. Files on most file systems have this special bit that says archive. And when the bit is on, that means the file has changed since it was last backed up and it needs to be backed up. Therefore, when you run a full backup, the backup software goes through and clears that bit and says, this file doesn't need to be backed up. The next time the file system makes a change to that file, it sets the bit, and that way your backup software knows it needs to back it up if you do an incremental or differential backup. The incremental backup only backs up those files that have been changed. So you do your full backup, which might be 1 terabyte per computer in your organization, and then only 20 megabytes of files have changed the next day. The incremental backup just takes those 20 megabytes and ships that across the network to your backup media. Makes it a whole lot faster, right? If you were doing full backups every day, well, you'd run out of backup media really quickly, but also you'd probably never get it done because full backups often take more than a week to do, even over a high-speed network. So the incremental backup just speeds things up and saves some space. The differential backup is exactly like an incremental backup, except it doesn't clear that archive bit. So imagine that you do a full backup and then a user changes file A. If you do a differential backup on Monday, and then a differential backup on Tuesday, and a differential backup on Wednesday, file A will get backed up every single time because the differential backup doesn't clear the archive bit. If you do an incremental backup, it would only be backed up that first day because the incremental backup says you don't have to back this up until the file is changed. We'll talk a little bit more about why differential is useful in some cases. Next, a copy is exactly like a full backup, except it doesn't clear that archive bit. It's literally just copying files, and the next time you go to do a backup, those files are going to get backed up again anyway. A copy is useful if you need to do an offsite backup of everything, but the next time you run a backup, you want to have those files backed up again locally so that they're immediately available. Snapshot is a little bit different from a backup. Full backups will literally just copy every file over. The snapshot generally looks at your hard drive at a lower level, and it will take a system image, basically make a virtual hard drive, and store that in the backup media. Full backups, they tend to focus only on user files, and they won't bother backing up system files, applications, etc., because all that stuff will be restored when you just restore from a system image. Snapshots back up and restore all of your system files and applications. So in enterprises where most companies use a system image and redeploying a computer takes just a few clicks, they use full backups and they don't back up system files. In home environments where you have one or two computers, you don't have a system image and you don't want to be bothered reinstalling every application and looking up every product key that you need for every application. So you take a system image, and then when your hard drive fails or there is a disaster, you restore from that system image and everything is automatically back up and running with no reinstalls. So here's the difference between incremental and differential. You can see I show schedules for both incremental and differential backups happening nightly. Now imagine that there's a failure in the world where we're doing incremental backups. Notice you did a full backup on Sunday and then incremental backups Monday, Tuesday, Wednesday, and Thursday. Next you have a failure on Friday. Well, that means to do a full restore, you of course start by restoring the full backup from Sunday. Then you need to restore the backup from Monday, Tuesday, Wednesday, and Thursday. Sounds like a pain, right? It is a pain if, it's 1998 and you're doing your backups to tapes, which is what we used to do. You'd have a backup tape for every day of the week, and when you had to do a restore like this, you had to go get the Sunday tape and stick it in and copy the necessary files from it. And because it was a tape, it took a long time. There's not random access really. It has to read through the whole tape. So it could take hours to restore something from the tape. Then you'd have to pull it out, and you'd have to put the Monday tape in, and you'd have to wait for that, and then put the Tuesday. It would just be a real pain. And so incremental backups, they're inefficient, but they make things easier to restore for the poor sysadmins. Now, this scenario involves tapes, but nowadays we back up to random access media. We back up to drives, basically, because drives are cheaper than anything else. And with drives, backups are a lot more intelligent, and you don't really have to worry about doing differential or incremental backups. It just kind of monitors the state of all files, and the software makes sure that everything is available at all times in the backup. And then when you need to do a restore, all the drives are online and readily available to you. That's something a younger person might take for granted, but an older guy like me who had to pull tapes, I appreciate that as being somewhat magical. Anyway, I felt like I needed to explain that because the difference between incremental and differential doesn't necessarily make a difference in the real world now. But this is the kind of thing you might see on a test, or maybe you're just having a conversation with an old guy. So to explain differential really quickly, in the same scenario you do differential backups and you have a failure on Friday. Also, here you only need 2 tapes, because Thursday's backup has a complete copy of every file that was changed on Monday, Tuesday, and Wednesday. So you do your full restore, and then you just do your most recent differential restore. Incremental, on the other hand, doesn't have any duplicated files between Wednesday and Thursday unless they happen to change on both days. Let's talk about where you store your backups. Most organizations, if they have backups, they certainly have it on site. On-site backups are cheap and fast because you can just run gigabit Ethernet between your backup servers and all the servers that you need to back up, and then they just copy the files over that gigabit Ethernet. Here's the problem, though. When that asteroid hits your building, your backup is destroyed as well. And because of that, you need an off-site backup. The off-site backup stores the backup at a different geographic location, hopefully someplace that's far enough away that it won't be impacted by the same disasters. There are a couple of different ways of doing off-site backups, and they're all kind of slow and expensive. If you have a lot of data, what you end up doing is backing up to hard drives or some other type of storage, and then pulling those hard drives out and putting them in a truck. And there are companies that offer this service. They will drive to your organization and pick up the backup drives every day, put them in a big box, lock the box, and then they take it far away to your backup storage facility. And then if you need a backup, you just call them and you tell them which day's box you need, and they come back and they drop it off for you. So you got to pay that guy. He's got to come in a truck, right? He's burning gas. So that's a lot more expensive than just backing up locally. But it's the only thing that's going to save you if your local facility is destroyed. And that's a more common scenario than you might think. It's more than just a random asteroid hitting your building. It can be theft. It can be fire. It can be flooding. It could be even a serious power surge that damages both your primary systems and your backup systems. So why not just use an offsite backup? The reason is it takes too long to restore an offsite backup. Can't tell you how many times a user has called and said, I just deleted something accidentally. I need it right now for this meeting. Well, if you have on-site backups, you can restore that file just about instantaneously. But imagine he needs it for the meeting and you say, well, sorry, I have to go call Iron Mountain, our storage facility, and they'll send a truck out, and it should be here in the morning, and then we have to pull the drives out of the box and load them up, and that's going to be unacceptable. That delay is unacceptable for most organizations, so you need to have an on-site backup to provide rapid recovery, and then an off-site backup to provide geographic distribution of your backups. I want to introduce the term back out. Now, we know what a backup is. That's used to restore your data if something gets corrupted or something fails. Back out restores your systems to a previous point in time. Backups are centered around restoring your computers to the most recent time possible, but that's not always what you want. Imagine you find out that a hacker got into your systems a month ago and they wreaked havoc. They compromised all the computers in your organization. They added lots of user accounts for themselves. They changed a ton of system files. They went in and corrupted your documents, ruining the integrity of all of your data. They inserted random transactions into your databases. It sounds like a nightmare, but it happens. And what you need to do is you need to back out. You need to figure out when that person got into your organization, when they started corrupting things, and restore a backup from that point in time. So that's backing out. Now, a good backup setup will provide for both recent backups and backing out to an earlier point in time. Of course, this requires more storage. A true backup just keeps one copy of every file on your computer, but most modern backup systems keep as much of a history as they have storage space for. You even see this in consumer backup software, like the stuff that comes free with Windows and Mac. They will keep 10 different versions of a file that you're actively working on, and every time you back it up, they will just add a new copy of it. That means that they eat all of your backup storage space. You can connect a 10 terabyte drive and it will eventually get filled up, even if you're just editing small numbers of files, because it will keep an indefinite number of copies. But this lets you go back to a version of your file from 2 years ago. Besides restoring from malware, it can also help with version control. I mean, I'm also a writer, and there have been times when I messed up something and I thought, oh, I had that perfect a month ago, if only I could go back in time. Well, you can with a back out. It helps with data corruption. Sometimes a file will become corrupted. Maybe the application freaks out and overwrites your data and you don't discover it immediately. You realize, oh, my application messed up my data a month ago. What am I going to do now? You go back to the archive of that file from an earlier point in time and restore the non-corrupted version. Just to wrap up, here are some tips. RAID is not a backup. I hear this all the time. Do you have a backup? I'll ask people, and they're like, I got RAID 5, I'm fine. No, you're not fine, because you know what? RAID controllers mess up sometimes. The whole RAID can go. Sometimes there'll be a power surge and 2 of your drives will fail at once. A thief will come along and steal the whole RAID array. And then RAID's not protecting you from anything. RAID helps keep your data online in the event of a failure, but it's not a backup. RAID also does not protect you from file corruption or accidentally deleted files. You need to have fire drills. And I will tell you an embarrassing story about a past life when I worked at a very high-end and expensive hosting provider, and we hosted for thousands of really huge companies, a lot of Fortune 500 companies, and one of these Fortune 500 companies had some really important services hosted at our organization, and one of their computers failed. So we're the hosting provider. Of course, we rushed in with a replacement computer and went to restore their backup, and it wasn't there. And I talked to the backup guy, and I said, help me out with the software. It doesn't seem to be finding the backup. And he says, oh, that hasn't worked in like a couple of months. Seriously, that's what he said. He knew it wasn't working. He just didn't get around to fixing it. He was busy with something else, I suppose. Backups are one of those things where you don't notice if it breaks. You don't. Sometimes your backup drive fills up and there's no room for new backups. Sometimes there's a misconfiguration that causes it to be stored in the wrong format or encrypted with a key that you don't happen to have access to. Sometimes you'll install a new system and it won't get added to the backup system properly. The only way to test this is to have a fire drill. With a fire drill, you pretend something has failed, a file has been lost, and then you go and retrieve it. And if everything works, then you're good. If it doesn't work, you'll find it out and you'll know to fix it right away. You should also verify the integrity of data. This used to happen with tapes more than it does with modern backup systems, but your data can get corrupted while it's sitting on the backup drive. So make sure that the data integrity is intact, and make sure that the files are recent too, because you don't want to accidentally restore a month-old backup and think that it's a recent backup. You also need to provide equal or better security for your backups, and I have a story around this too. We had another failure, and failures happen, right? But this time we actually had the backup, so that was great news, except when we restored the files, we restored them in a way that wasn't protected. And that's really not what the client was so upset about. He was upset that we had access to all of his unencrypted data, because on his primary system, he'd gone through great measures to make sure that his files were secure, but when we restored them, we didn't maintain that security. So your backups need to be protected so that your backup operators can't read the data, because you don't trust that guy, right? Just like with systems administrators needing to have the access to data restricted, your backup operators shouldn't be able to read the data that they're backing up. It should be encrypted in some way, and it needs to be physically protected, at least to the amount of security that you require for the primary system. Because backup systems tend to have a mix of highly confidential data and less confidential data, I say protect it like every bit there is confidential. Because backup systems tend to have a mix of data from different confidential and not so confidential systems, I say treat backups like they're all highly confidential. The next is to automate everything. And oh my God, I have a lot of stories about backups, but on one of my first jobs, we had a single tape drive for backups, and it was my job to go in there and change the tape out every day. And sometimes I forgot. And you know what? I didn't remember that I was supposed to change the tapes until we had a failure, and then I went to restore it from a backup, and I had to say, I'm sorry, the most recent backup I have is a week old. So the person I was restoring the file for lost a week of work, and I was terribly embarrassed. And it's because it was a manual backup system, and really that's not a maintainable system. You cannot expect somebody to do anything on a regular basis. backups need to be completely automated, and that's one reason I'm glad tapes are gone. For the most part, we're using big drives now, and they have plenty of space, and they'll back up even if you don't show up for work for weeks. They'll just keep running and running and running. This also means that you can't count on Joe, the backup operator, to put the backup drives in the back of his truck and take it home once a month for your offsite recovery. If you rely on an outside organization who shows up at your door every day, that counts as automating it. If you just tell some guy to do it on a regular basis, he's going to forget, like Tony did many, many years ago, to do it, and then you're just out of luck. I also suggest if you are backing up across a network that you have a dedicated backup network. It can be a big mistake to have a single network for both regular transactions and backups, because backups are big. If you back up a full system and it needs to send terabytes of data across the network, that could saturate the network for days. And if you have hundreds of systems, that backup network can be at full throttle indefinitely, and that can slow down your regular traffic. So especially for servers, what I'll do is I will plug 2 high-speed network adapters in, and one of those network adapters goes to the front end, clients that are connecting to the database or users who are browsing the web server. The other network adapter will go right to the backup network. This just separates them. It prevents the backup network from slowing down the primary network. You also need to back up your mobile devices and computers that people use at home that might have confidential data on them. Sometimes organizations will assign PCs to users and they only get backed up when they're actually in the office. Maybe they have a USB drive attached to it, and whenever they put the PC in the docking station, that's when it gets backed up. If the user is on business trips for a month, they don't want to lose a month of data. So you need to find a way to back up their stuff across the network. And you know what? It's not going to work to tell them to carry the USB drive with them and plug it in the hotel room. Why? Because automate everything. That guy's not going to pull his hard drive out after a long day of work and plug it in. You have to automate that, which means you have to do it across the network. He probably will connect to the internet, so he can at least check his Facebook. That's a good time to back it up. You can use online cloud-based backup services like Carbonite or others. I'm not endorsing Carbonite specifically, but they're a popular example. And they will just back up your computers across the network and keep it secure. That counts as an offline backup too. Now let's talk about high availability. When restoring your stuff from a backup isn't fast enough, you go over to HA and you keep stuff running even if there's a failure. Now I'd like to talk about many of the different availability techniques that you can use to get stuff up and running when they fail. The first is just to keep spare parts around. I've had a network adapter fail in a server, and then you go to replace it and it's going to take 2 days to get in. So is your server just offline for 2 days? No, you'd keep an extra network adapter around, especially if you have more than a few computers. Extra network adapters, extra hard drives, heck, just keep extra computers around. Then you can just pop them in and get them started, and you reduce your downtime quite a bit. A cold spare for a server often doesn't even have hard drives plugged into it. You'll have your hard drives in the main server protected by RAID, but if something else fails, a motherboard, a network adapter, you just pull those hard drives out of the hot computer and you plug it into the cold spare. Then you plug that cold spare in and it assumes the personality of the original server, and your downtime is only a few minutes. The difference between a cold spare and a hot spare is that the hot spare is online and it comes on automatically. The cold spare requires you or somebody to go walk to the computer and do something physical with it. The hot spare can detect the failure of the computer that's offline and basically start right up. Often with hot spares, you'll have a shared storage device that's connected to both of them. Think of it as a big external RAID, and it's plugged into a computer that's on and a computer that's off. If something happens to the computer that's on, well, it'll shut down automatically and the backup computer will just fire up. You can also have internal redundancy for a variety of different components. RAID is the one that everybody knows, where you'll have 3 drives and only 2 of them will be in use. And then if one of the drives fails, the third drive just takes over. You can also have redundant network adapters. Network adapters frequently fail, so heck, put in 2 network adapters, wire them both into the same network, and configure them for failover. Lots of software will allow you to do this, and if there is a failure in one, it just starts using the other one. You could even route the two network adapters into two different networks. And then if a piece of network equipment fails, the other network adapter will just take over, routing it through a different network adapter and different network hardware. I have a network diagram that demonstrates redundant networking equipment later on. Next, you can do lots of online failovers. These are clusters where servers are redundant to each other, or even a server farm where you have 5 or 10 or 20 different servers all doing one thing, and if one of them fails, the other ones take over. I have a couple of slides later on that provide more information about online failover. Finally, the big daddy of availability is geographic distribution and synchronization. Set up the exact same equipment at a faraway place and then synchronize all your data in real time. That way, whatever failure happens, you can just switch everything over to your backup site. Almost no downtime. I just want to quickly go over the different RAID levels. RAID level 0 is striping. This provides absolutely no protection at all. It just provides a performance improvement by writing any given block of data to multiple disks. That way it can write to multiple disks at the same time and read from multiple disks at the same time, and it overcomes the frequent bottleneck that is the drive performance of a single drive. RAID 0 doesn't always increase performance. Sometimes your bottleneck is the system bus or some other element, so use it with caution. RAID level 0 actually increases your chances of failure because if you stripe across two drives, well, you lose all your data if either of the drives fail. So it's really important that you have some sort of backup in addition to that, and just know that you're getting some extra performance, but you're taking an extra risk too. RAID level 1 is disk mirroring, and it's the simplest of all RAIDs. You just have two drives that have an exact copy of the same data. Every time the computer writes to one drive, it writes to the other drive. That way the second drive always has an exact copy. If the first drive fails, the computer just picks up where it left off with the other drive. RAID level 1 can improve read performance because it can read from both drives simultaneously and overcome that performance bottleneck that can be a single drive. However, it can slow down write performance a little bit. Not always, it depends on how it's configured, but it does have to write to two different drives at once, and depending on how your system is configured, this can slow things down a little bit, or it might not at all. RAID level 5 is the most efficient way to provide redundancy. With RAID level 5, you can configure 3 drives to act in a RAID array, and you'll get the storage that you would out of 2 of them. So if you have 3 1 terabyte drives, you'll have 2 terabytes of storage, and if any one of those 3 drives fails, you will be able to continue to access your data. I don't know how that works. It's somehow magical. Somehow you could pull out any of those 3 drives and 2 of them would continue to work just fine. You wouldn't lose any data. You can have 10 drives and you will have the storage space of 9 of them. Pull out any one drive and it continues to work. So RAID 5 uses space really efficiently, especially as you need to grow beyond just 2 drives. I will say if you have a failure of a RAID 5 array, it's really important to take out that failed disk and put in a replacement disk, because RAID gets really slow when one of the drives fails, because RAID has to do all these parity calculations. It has to figure out all the missing data by doing a bunch of math, and that can make both read and write times really slow. RAID 5 also slows down write performance even when things are going well, because whenever it writes a new bit of data, it has to do these parity calculations and write that extra data. So RAID 5 is not the best for performance, though it's okay. It doesn't slow you down too much. RAID 6 is a lot like RAID 5, but it has dual parity. So instead of just pulling out one drive and having things work, you can actually pull out 2 drives. That also means that you don't lose your redundancy when a single drive fails. It is common for 2 drives to fail simultaneously, especially in a large array. The fact is, you probably bought even an array of 10 drives altogether. They all came from the manufacturer as part of a single batch. Therefore, if there's some weakness that might cause them to fail in a month or a year, they could fail at about the same time. Drives often have what we call a mean time to failure. And if drives come from the same batch, if they're the same model and they come from the same manufacturer, they tend to fail about the same time. RAID level 6 helps reduce the risk of that sort of failure taking you offline by allowing you to lose 2 drives in a set simultaneously. RAID 10, it's really 1 plus 0. It's mirroring and striping at the same time. So if you had 4 drives, you'd get the storage capacity of 2 drives. You basically stripe your data across 2 drives and then mirror that RAID 0 array. It provides improved performance with the 100% redundancy of disk mirroring. With RAID 10, you can lose half the drives in the array and it will continue working. And there can be a performance hit as you're writing data, but performance is great while you're reading it. So let's talk about load balancing in a server farm. The way load balancing works is it takes incoming requests from clients and distributes it across different redundant servers. This provides both scalability and availability. This is common for many different types of applications now, but it's been used for a long time with web servers. Web servers often have to serve millions of people simultaneously, so they need to set up thousands and thousands of servers that do exactly the same thing. They're serving the exact same web pages. And what happens is an incoming request from a client is received by the load balancing device. The load balancing device takes a look at the request and says, okay, this is a legit client and they want the about page for the website. I have 10 servers that can serve the about page. Which of these is the least busy? And then it sends it to that server. Usually the load balancer will send requests from the same client back to the same server, so it's sticky that way, but it doesn't have to be. If one of those servers fails, well, it just takes it out of the loop until it's repaired. That way you get the performance of however many servers you have currently online, and if any one of them fails, well, you lose a little scalability, but your site stays online. Server farms are great for apps that can be easily distributed and synchronized. Web servers are extremely easy to distribute and synchronize. Usually you just need to copy over all the files on the web server to another web server, and then they assume the exact same personality. You can take them offline, swap them out. It makes no difference whatsoever. Some apps are much harder to synchronize like that. Databases have gotten easier and easier, but that can be difficult. And if an app wasn't designed to be used in a server farm, for example, email servers are often not designed that way, a cluster can be a better solution. With a cluster, you take 2 or more servers and attach them to a single shared storage device. So anything that's being permanently written is being written to the shared storage. Then the servers can communicate with each other just to let them know that everything's going okay. There's what they call a heartbeat going between the 2 computers. And if that heartbeat fails, if computer B doesn't hear from computer A for a few seconds, then it thinks, oh my goodness, the primary partner here is dead. I need to fire up and take over these services. Usually clusters assume every part of the primary server's identity, the host name, the IP address, the MAC address, everything. That way incoming connections are seamlessly transferred over to the backup, and usually there's no noticeable downtime at all. That's kind of the ideal with a cluster. Clusters can be pretty complex to configure. They can also be pretty costly to set up, but if a service is critical and you can't handle it being down for an hour while you're repairing something or putting in replacement parts, then you need a cluster. This ugly diagram shows redundant networking. Up at the top we have the public internet there, represented strangely in green. And in this organization we have redundant connections to the internet. That way if this ISP connection fails, all the traffic can be rerouted through this backup connection. This organization also has redundant firewalls. Because all traffic needs to go through a firewall, if you need a redundant connection to the internet, you're going to need redundant firewalls. Now, notice that both of these firewalls have 2 network connections. They needed to be connected to both routers so that if either one of these failed, they could continue working. Now, if we didn't have these 2 connections, then if this router failed and this firewall failed, then we wouldn't have a path to the internet. But by providing 2 connections for both firewalls, we actually have even more redundancy. This represents the LAN, and you'll notice that it too is redundant. Every component that's critical is connected to the 2 LAN devices. That way, if this cable breaks or this switch fails, the communications can continue through the other piece of networking equipment. Finally, you'll notice that servers are connected to a redundant storage device. This would be protected with RAID or something else that would allow it to continue to function properly even in the event of a drive failure. In this way, we have multiple levels of redundancy throughout the entire connection, and we can withstand the loss of any single device, but quite possibly multiple devices, as long as we don't, say, lose both firewalls. This is Tony Northrup for Train Signal, and thanks so much for watching this video lesson.